Example 6 says analyze the equation, that is, find the vertex, focus, and directrix, and graph. Okay, what's the problem with this? Same way we've ended the last 3 conic sections, or all 3 conic sections. This is in general form. And I need to put it into one of these forms. So how do we do that? By completing the square. So this time I can see I only have an x squared. So it means this negative 4y needs to get moved over as well. So I have x squared minus 4x, leave some room, equals positive 4y. Now when I have my b over 2 squared, what am I adding in here? Well, my b is negative 4, so negative 4 squared, goodness. Negative 4 divided by 2 is negative 2, squared is 4. And what I do to one side, I've got to do to the other. So what does this factor become? What multiplies to 4 and adds up to a negative 4? That's negative 2 and negative 2. Over here, I need to pull out my GCF if I have one. They both have a 4, so I'm going to pull that out. And that leaves me with y plus 1. So now this is my equation that I will use to find these 3 things. So we need vertex, focus, and directrix. Okay, well, I have my focus just by looking, or my vertex just by looking at this. My vertex is h comma k. So here is my h, and my k is negative 1. Now for focus and directrix, I need my a. So let's compare our equations here. Which equation would this one be? The first, second, third, or fourth one? And that's this first one right here. You have an x squared and then a positive 4a. So I'm going to write this equation just right here below. This is x minus h squared equals 4a y minus k. So I purposely spaced this out properly. You can see your x, your h, you can see your y, and your k. So what are we kind of comparing here? These two here. So if I have 4a equals 4, that tells me that a equals 1. So now I can find these here. You can either use these formulas. So if I use this formula for focus, we have h is 2. Let me write that here. This is my h. This is my k. So we have h is 2. And then k plus a. K plus a is 0. And then my directrix is y equals k minus a. So negative 1 minus 1 gives me negative 2. Here are the 3 things that they asked for. But I like to just graph this. So if my vertex is at 2, negative 1, and I know that this is my formula here. From that vertex, I need to go up to plot my focus. And my a is 1, so I'm going to go up 1. Here's my focus. which is at 2, 0. And then from my vertex, my directrix is below. So I'm going to go 1 unit down. And here is my directrix line. At y equals -2, which we got here. Okay, then the last thing I need is my lattice rectum length, and that is 4a. So if 4a equals 4, there is my LR. This is the total length. So I'm going to take that and divide it by 2 to get 2. So from this focus, I'm going to go 2 to the left and 2 to the right. So when I graph, we'll graph from vertexes through those LR points. And you can see I have a total length of 1, 2, 3, 4. Let's do another similar one right here. On this one, I can see I only have a y squared, no x squared. So I need to move and it looks like I have a note here. Sorry. I am changing this problem, so I'll change it as soon as I get done recording. But yours should already be like that in your notes to an 8. Okay, so I'll make sure that that is done before I do it. I'm gonna put just a little sticky note here. Okay, analyze the equation. And that is, again, find the vertex, the focus, and the directrix. So here I can see I only have a y squared. So I want to leave my y's where they are. I'm going to leave some room. But then I need to move my x, because it doesn't have an x squared, and my constant over. So now we have equals -8x minus 25. So let's figure out what we're going to add here. And we use our b over 2 squared. So my b is -10. -10 divided by 2 is -5, and -5 in parentheses squared is 25. I will also add that over here. So what does this factor become? What multiplies to positive 25 and adds up to a -10? Y minus 5 times y minus 5. So that's y minus 5 squared, which is your -10 over 2. And then this equals, these cancel out. I have -8x. So we need vertex, focus, and directrix before I do that. Actually, let's figure out which formula we have. So comparing what I have here, let's try this the right way. With what we have here, are we using the first, second, third, or fourth formula? Pause the video if you need more time. Because we have a y squared. Here's my y squareds. And it equals a negative, so I'm using this one right here. So if I compare, this is y minus k squared equals -4a x minus h. So then my vertex, you always go x, comma, y. If I have nothing in parentheses here, that means my vertex is at 0. And then come back over here to my k. inside opposite, so that -5 is the +5. Now, I'm going to go ahead and use the graph to find these here, but you can use those formulas given here if needed. So my vertex is at 0, 5. And actually, whether you want to use the formulas or the graph, we need A for both of these. So when we look at this, what's kind of on top of each other? Remember, this would be the same as x minus 0 in parentheses. So what we're comparing is this -8 and this -4a. So -4a equals -8. So a is 2. So if I'm using the graph, I look at the relationship between my vertex and the focus and the directrix. From my vertex, my focus is to the left. So I'm going to go to the left 2 units here for my focus. So now my focus is at -2, 5. Which is what I get if I use this. Here is my H and my K. So if I do H minus A, we have 0 minus 2 to get -2, comma K, which is 5. Then my directrix is going to be behind it. If I go 2 units in the opposite direction, we are right here at x equals 2. So x equals 2. Which is again what you get if you use this formula. We get x equals h, which is 0 plus a. So 0 plus 2 gives me 2. So here are my answers to the questions it gives. And I will finish graphing this. My LR equals 4a, which is 8. So this is my total length. So take this and divide it by 2 to get 4. So from my focus, I'm going to go down 1, 2, 3, 4. From my focus, I'm going to go up 1, 2, 3, 4. And there is our parabola with a total lattice rectum of 1, 2, 3, 4, 5, 6, 7, 8 units. Now, before we stop this video, let's go over our bonus question for the last time here. And this wants to know, in lesson 5, we discussed how we knew that this was a circle. How do we know that this equation was a circle? There's 3 characteristics. Pause the video if you want to think about it or look back at your notes. We knew that this equation here was a circle. Here it is because we have both x and y squared. We have the same sign, both positive and same coefficients. It's 1x squared and 1x squared. In lesson 6, we talked about how we knew that this equation was an ellipse. Pause the video if you want more time to think. But how did we know that this equation was an ellipse? We had 3 characteristics as well. Okay, here's that equation. We knew that this was an ellipse because we had both x and y squared. Still same signs, positive and positive, but now we had different coefficients. So that's what made that circle kind of stretch one way and make it more oval or ellipse-like. So we had a 9x squared, but a 1y squared. Last lesson, we talked about how this equation here, and it's split up, but this is the important bit, was a hyperbola. How did we know that this was a hyperbola? Okay, pause the video if you want more time. We only had 2 characteristics here. First, at both x squared and y squared, we had x squared. Oh, where are we at? X squared, y squared. But this time we had different signs. A negative x squared, but a positive y squared. So that told me it was a hyperbola. What characteristics make 6 and 7 a hyperbola? Oh my gosh, if I could read. What characteristics make 6 and 7 a parabola? And what made these two a parabola? We talked about it in the very first video when we were comparing all of our equations. The key here is how many squared terms do I have, right? This one has only an x squared. This one here has only a y squared. So what characteristics make 6 and 7 a parabola? And I should even just say what characteristic. These are parabolas, and I can tell by just looking at them because they only have one squared variable.